Okay, so we collected the data and we want to store it, but not locally on the sender. We want to store it actually on the cloud. So we have to communicate that data to the cloud. We've already communicated the data from the sender to the receiver, and what we want now is to send it to the cloud for storage. So let's take a look at how we would do that. Let's jump right in. Okay, so in the last video we left off at the LCD. We were able to receive the data, like I mentioned, from the Nano at the Uno via NRF radios, and we were able to not only print it on the serial monitor, which is fine for debugging, but to display it on an LCD. And this is where we actually left off. So now let's actually get this data up onto the internet using Wi-Fi. So Wi-Fi is also kind of radio. It is a radio, and it is obviously used for much longer distances, and more specifically for internet access. So what we're going to be worried about here is how do we communicate with the internet? We know how to communicate between MCUs, but let's actually communicate with a server on the internet, and this is what we're going to do now. Okay, so there's two ways of doing this, and we're going to stick with the simplest one. So we can use AT commands that the Uno can relay to our Wi-Fi module via its serial port, and then the Wi-Fi module will execute those commands and execute, well, the corresponding Wi-Fi task. The other way of doing it is to use the Wi-Fi module as a standalone, because it actually has a microcontroller in it as well, which can be used by itself. We will look at that in a later video. It is much more friendly because it uses a library. It is easier, obviously, and it is also more stable, as we will see. But we'll start with the simplest of all, which is AT command. So depending on if we use the MCU middleman or not, wiring is done in a certain way. So here's our MCU middleman, and here is our ESP8266 module. And as you can see, the connections are pretty straightforward. There's ground and a 3.3 volt, not a 5 volt. This is a 3.3 volt power. And the connection from 3.3 volt MCU to the Wi-Fi module is actually also bridged over to a CH pin. And then there's an RX and TX, and it's peculiar because RX actually connects to RX in this case, and TX connects to TX. So, alright. Okay, so open up the serial monitor, and obviously you should have connected your microcontroller to the USB port on your computer, and if you send AT, you should receive the infamous OK response, so check that out first. And next we're going to try to connect to your SSID, so enter the Wi-Fi name of your SSID and your password, and go ahead and click on send. Okay, so as you can see, we have connected and we have gotten our IP. So this is the response that you should get in the serial monitor. Otherwise, you might have crossed your RX and TX lines, or you might not have bridged the 3.3 volts with the CHPD pin. So go ahead and check your connection on your Wi-Fi module before continuing. Alright, great. So let's go ahead and get some data. In case you guys are wondering how to program the ESP directly without the MCU middleman, there is some pre-configuration you have to do. So in this case, on the left, we're going to use the Wi-Fi module directly, which means that we need to use a library called the ESP8266 Wi-Fi library, so that we can send it commands as nicely as begin and client print, etc. So, but in order to do that, we also, because we will be writing directly to the ESP and not to a microcontroller like an Uno, we need to bring in something from the board's manager in order to recognize the ESP as a microcontroller. To do that, we go to our preferences, and we add in this URL resource, which is where we will get our ESP8266 boards, and just enter that down there in additional board manager URLs, and go ahead and click OK. If you already have one, just hit comma after the one you have, and then just paste that right in there. Alright, once you have that, go ahead and click OK, and now go over to Boards Manager from your Arduino IDE, and look for the ESP8266 by typing that into the window top right. And at this time, the latest is 2.5.2, so I went ahead and selected that and clicked Install. And once you click Install, make sure it's the one from the ESP8266 community. Once you hit Install, it'll go ahead and do its thing, download and install everything required, and you're done. Another thing that needs to be done, like I mentioned before, is download the ESP8266 Wi-Fi library. You can also get that in the library manager from your Arduino IDE, or you could go ahead and download it from GitHub. If you want it from GitHub, it's right here. As you can see, the ESP8266/Arduino, and you just go ahead and download everything here using the download zip option. And once the library has been downloaded to your computer, go ahead and drop it into the libraries folder. If you're a little bit more advanced user, you could also go ahead and use the library directly from the downloaded zip file. There's an option for that in the Arduino IDE, but if not, just go ahead and unpack it, throw it into your libraries folder, and it'll be ready to roll. Okay, perfect. So with the library added and the boards manager configured, we are now able to use the ESP Wi-Fi module as a standalone, which means that the sketch that we write in the Arduino IDE is going to go directly into the ESP Wi-Fi module, not onto the Arduino Uno board as we did before. Okay, so just keep those two scenarios separate, because in one we use the middleman and in the other one we don't. Okay, so if we're going to lose the MCU, then we're going to wire it differently. Okay, if we're not going to use the middleman, the wiring is different. Ground is always ground. The GPIO is actually also connected to ground. RX and RX and TX and TX are still fine. The CHPD is still 3.3 volts, and so is the VCC. So the difference here is that we're using the GPIO pin to ground in order to tell the ESP module that we are trying to program it directly. Alright, not that complicated, so let's go ahead and go to our boards, and in this case we can see the ESP8266 boards down there, 2.5.1. That's the one we're going to want to select, because in this case we are going directly to the ESP board. We are losing the middleman, and this is going to tell the Arduino IDE to upload our sketch directly to the ESP, not to the Arduino Uno. Okay, and then once you select the generic ESP8266 module, as you can see, you get a few options. One of the more common ones is the 512 versus the 1024K memory, and that has to do with the color of the board. So the blue boards are the older ones, and they're 512, and then the black boards, which is in our case, I'm using a black one, and it is 1024 or 1 meg, which is the fourth one or the fifth one from the top. All right, so we're ready. Okay, so we are ready, and we are going to try out a very simple sketch. As you can see, we're only going to be writing GPIO2 because the ESP Wi-Fi module also happens to have an LED connected to this pin. So we're going to use the library in order to write a sketch, to upload this sketch directly to the ESP8266 and tell it to digital write high and then low to its GPIO2. Alright, so the library. This makes everything easier. If we include the library, we are able to do stuff like this. We can check the mode of our ESP, we can disconnect, we can go ahead and print to it, scan networks, etc. So go ahead and upload this to your ESP module now. and go ahead and click Run. You can go ahead and open your serial monitor, and you're going to see the following results. Scan starts, and in my case it found 5 networks, and there they are. So that's pretty much as complicated as it's going to be. Basically writing commands to the ESP as you would to an Uno. Okay, and this is the best way to go forward. However, we are going to use or we're going to get to know other options as well. Alright, so in this case we are going to upload this sketch, and we're going to be able to go ahead and connect to a network. So go ahead and upload this sketch now to our ESP8266, and it's uploading. There it is, ready. And in this case we're also going to get to see what IP address our router actually gave us. Alright, so there we go, and this is a sketch for browsing the internet. Believe it or not, you could actually browse the internet on the ESP on your serial monitor. So go ahead and upload this sketch, your SSID, your password, and you get your HTTP begin. And in this case, what we want to request is google.com. So we're actually going to get the google.com website, download it, and view it in our serial monitor. Alright, so hope you guys enjoyed it, and I'll see you in the next video where we're actually going to use the Wi-Fi module to send data to the internet, which was our original purpose. So I hope you guys enjoyed it. Don't forget to like, share, and subscribe. See ya.